All right, today's date is Tuesday, October 15th. I am your host, Mrs. Sindel. Today is Gender Bender Day. 10/15, 2019. Analytic analysis. It is our final lesson of the entire unit, which means tomorrow is a self-check. Today we're talking about concave up, concave down, and inflection points. Our objective today, who wants to read it?
Find where the function is concave up and concave down and has inflection points without the graph.
There it is. All right, so a review of the first derivative test of the f prime test. If I have a function, I first will do what? You guys got this. We've been doing it all week. F prime of x. Cool. Someone do that.
3 plus 6x. 4x.
3x squared plus.
You're right.
There it is. 3x squared plus 4x. And let's find some CVs. So I'm going to do this in green. We'll find the CVs. Here we go. The two things that will make you have a CV is where f prime
Use 0.
or where f prime. And generally speaking, f prime equals 0. Is that top or bottom equals 0? So top equals 0, and DNE is where bottom is equal to 0. All right. Here we go. We don't have a bottom to deal with, so that's not going to happen. But I'll leave it there just in case people need it. And here we go. I'm going to set this to 0. I'm setting the derivative equal to 0, not the original function. So I have 0 is equal to 3x squared plus 4x. Oh no, what do I do from here? Take out next. So I have 0 is equal to x times what? Someone?
3x plus 4.
So far so good. Zero product property tells us one of these sides, x is equal to 0. The other side, we'll do in blue. The other side is, what is equal to 0? You already did all the math. Negative 4/3. So you get 3x plus, that's a bad plus 4 is equal to 0. Subtract 4, so you get 3x is equal to negative 4, and then finally x is equal to negative 4 over 3. Whew. All right, there's the f prime test. In essence, we need to now make the number line. Yes, I gave myself room to do that stuff down there. We'll make our number line up here. That's a good spot for it. And mark all of our CVs. We have 2 of them. Which one goes first? Is it negative 4/3 or 0? Yeah, okay, so negative 4/3 and 0. This is a graph of x, by the way. Let's label those things. Those are CVs. CVs. What next?
Test points.
Test points. What should our test points be? Far left. Farthest left should be. Sure. Let's try negative 2. In between.
1.
Ooh, careful.
Wait. Yeah, negative 1, right?
Negative 1. Yeah. And then far right. 1. That's a good test point. Do we actually need those test points? Each of these is to the power of 1, right? So if we just find one of them, then we're good. Which one of these is the easiest?
Negative 1. Actually 1.
I think 1 is probably the easiest. So if we plug in 1 into the factored form of our f prime, if I plug that in, then I'm going to get, is this part going to be a positive or a negative? Positive. Is this going to be a positive or a negative?
Positive.
All right, so this is going to be a positive, and therefore someone call it out. It's going to be
Wait,
increasing.
Can you repeat that when it's a positive and a negative or odd, whatever?
Yeah, so I'm looking at not even odds or evens yet. Ignore the ones for now. Just plug in 1. 1 times x, or 1 is x, so 1 is positive.
Okay.
And then if I plug in 1 here, 3 times 1 is plus 4 is, yeah, so it's positive.
Okay.
Positive times positive is a positive over here.
Oh, so you're just plugging in your test points.
Just plugging in the test point 1. Now that I've plugged in the test point 1, my shortcut that I'd like you guys to be comfortable using is knowing what power I have. I have a power of 1 for the CV power of 1 for the CV 0. I'm looking at this CV. That's the CV I'm going to jump over. So I'm looking back here at x. That's the CV that gave me 0. And is that going to change signs?
Yes.
Yes, because it's an odd power. That's a negative. Therefore, this is f decreasing. What about this critical value at negative 4/3? Where did that come from? Which linear pair? Oh yeah, this guy. Is that to a power of an odd?
Yeah.
You say yes. Therefore, what can you conclude?
That's going to be negative.
But the sign changes.
It's going to be a sign change. This was negative. It's going to be a positive. It is a sign change, which means it's F increasing. Uh-oh, I feel like I lost Stego and Geo. Let's go through it one more time. Make sure we really get this. So plugging in 1, I think everyone was safe over here. We know it's positive. We know it's F increasing. I'm going to jump over this CV. This CV was 0. 0 came from either this one or this one. It came from the one on the left. The one on the left had an odd power. If it's an odd power, you do change the sign. If it's an even power, you don't change the sign. We change the sign from a positive to a negative, therefore it's F decreasing. Again, we're going to now jump over this critical value. This critical value of negative 4/3 came from this.
So if it's an odd power, you just change the sign.
Yes. It's an odd power. We change the sign from a negative to a positive, and therefore it's F increasing.
So it's going to be F increasing on negative infinity to negative 2.
Not to negative 2. Negative 2 is just a test point.
Oh, F negative 4/3.
Yep, so let's write it down. F is increasing from negative infinity to negative 4/3. That's what Gia just said. Or, where else is it increasing?
0 to
0 to infinity. Where are our critical values?
from 0 to negative 4/3.
Oh, you're doing the decreasing?
Oh,
We'll do that in a sec. What are our critical values?
negative 4/3
Negative 4/3 and 0. Sego, can you do where it's decreasing?
Maybe.
Where is our function decreasing? So it's decreasing between here and here, right? So what two critical values should I be bordered by? Negative 4/3 to 0. There it is. The second part of the first derivative test we learned yesterday, which is finding the relative extremum, finding the maximum, and finding the minimum of the function. So, relative extremum, definition, go. Relative extrema is where
the sign change.
f prime sign change. What is the definition of the function maximum?
Negative to a positive.
Careful.
Positive to a negative.
Positive to a negative. The way that you can remember this is you start with whatever you're given. If it's a max, it's positive. If it's a minimum, it's negative. You start with whatever that word matches up with. And then therefore a minimum, Claire, is negative to a positive. Let's give some more definitions. Era, what's the definition of a critical value?
F prime equals 0 or it doesn't exist.
There it is. Stego, then Geo. Stego, give me the definition of f increasing.
When x is greater than 0.
Not when x, but when f prime is greater than 0. And Geo, decreasing.
F prime less than 0.
There it is. F prime less than 0. Be working on the speed sheet. If you have spare time, do the speed sheet. I know that we're already not having enough time because we're not doing the homework, but if you finish the homework and you have spare time, review these definitions. You have to have them memorized. All right, so we know that f prime is where we have a sign change for relative extrema. Relative extrema, where are they?
CV, but only at the CVs, right?
It can only happen at the CVs. Do both of these CVs have a relative extremum? Okay, let's label it. So this is a, we'll just say relative extremum, relative extremum. And then we can come back down here and say, yeah, that happened at both of the CVs, at x is equal to negative 4/3 and 0. Where do I have a maximum? At negative 4/3. So we say at x is equal to negative 4/3. Where do I have a minimum arrow?
X equals 0.
There it is, x is equal to 0. Notice that you're always going to be using these values from the relative extrema. If you did not use both of these values in the relative extrema in the maximum and minimum, you have made a mistake. For example, if I had like a 1 here and I didn't use a 1 in the maximum or minimum, something has gone wrong. I've made an error somewhere. All right, now we're doing the second derivative test. You already know these definitions, so let's list them out. Where is f, the function concave up? What is the definition? Greater than 0. Where is f, the function concave down?
When f double prime is
Yep, and then we'll give it to Stego for the nice hard one. Where is the inflection point? Where f double prime, not where it's highest, it's kind of like the relative extremum, but with f double prime. So it's where f double prime, sign change. Yep, sign change. So that means we need to take the derivative again. So our first derivative was 3x squared plus 4x, so let's write it down again. F prime was 3x squared plus 4x.
so f double prime is going to be 6x plus 4.
F double prime is indeed 6x plus 4. And then we do that whole process again. We have to find, there's no such thing as CVs in the second derivative, so there's no word that I can use there, but we're going to find potential inflection points. That's what I'm going to call them. We're setting this equal to 0. There's not a name for what we're doing here aside from finding potential inflection points. So we're going to say, yes, set that equal to 0 now. So we're going to say 0 is equal to 6x plus 4. Therefore, x is equal to
negative
4/6 or negative 2/3. Make our number line again. We have a second number line. Where are our possible inflection points?
2/3.
Negative 2/3. I'm not even going to label that. Now we're going to check if it's an inflection point by doing a test point to the left and to the right and seeing if there's a sign change. If there is a sign change, then we know it's an inflection point. We can't even label this with anything. We can't say like double prime CV or anything like that. So let's go ahead and check. What's a good number to check from the left and the right? A negative 2 or negative 1 even works, right? Negative 1, and what's a good number on the right? 0. So again, you can use the same trick. 6x plus 4. Was that to the power of 1, power of 2, it was power of 1. So you know that it's going to switch signs. Just knowing that, you already know it's an inflection point because that matches the definition. It's going to switch signs because it's an odd power. If there's no power, you assume it's an odd power because it's to the power of 1. So we know it's an inflection point, but let's prove it by actually checking these. You can plug them in if you don't like Mr. Sindel's method of checking odd powers. You can plug them in. Let's plug in 0. Let's give that to Stego. Stego, plug in 0. 6 times 0 plus 4, which is positive or negative? Positive. Therefore, you can conclude this is F. You have one of these two to choose from. Yep, F concave up. You can plug in negative 1 again, and you will get a negative. Or you can use the trick that we know it's a odd power, and you know that this is going to switch over this inflection point. Now that we know it's negative, we can conclude that this is F. Someone shout it out.
F concave down.
And therefore, this point right here is
Inflection point.
inflection point. Perfect. Let's label all of our information. Our inflection point happened at x is equal to negative 2/3. Sometimes this won't be an inflection point. If it's positive and positive, that's not a change of sign. It's not going to be an inflection point. Where is the function concave down? On what interval is my function concave down? Or sorry, let's do concave up. Let's start with the beginning. Where is it concave up? From
0 to infinity.
not 0. 0 is a test point. Again, don't accidentally use a test point.
Negative 2/3 to infinity.
To infinity. And Claire, you want to do concave down? There it is. Do you include negative 2/3, Claire? No. Perfect. So I'm only going to give you one test problem, one example. I needed to talk to you. I should have done this back in 3-6, I think. Next year, I've already fixed this for the notes, so 3-6 has been updated. You need to know tricks with e, because I already gave you problems on the homework where I have e to the power of x or something like that, where I'm giving you e house.
Yeah.
So let's assume that my function is just plain e to the power of x. Let's plug in 5. Therefore, that is now e to the power of
5.
e to the power of 5. My question for you is that positive or is it negative?
Negative.
E to the power of 5 is positive because e is just like 2. Think of it as just a number 2. 2 to the power of 5 is positive. What happens, let's take a guess here. When I plug in negative 10, do you think it's going to be negative or positive? Exactly. So this is going to be e to the negative 10. And as Claire said, that's going to be 1 over e to the 10, which is still positive. So if I have a positive e to the power of x, I can never be negative. Nor can I be the value of 0. It will never be 0, which means I will never be able to get a critical value when I'm just dealing with e, or anything that has a base that is a constant and an exponent with a variable. E to the power of x will never give you a critical value. It will never give you an inflection point. When I factor something and I factor out an e to the power of x, that will never, ever, ever give you a critical value because I can never be 0. E to the power of x can never be 0. So if you want to make a note, no CV, no IP. Those will never happen when I have e to the power of x. Okay, let's say we don't know the sign. Let's say we have a times e to the power of x. If a is positive or a is negative, that will always affect what e to the power of x is, which means a times e to the power of x will always be the sign of a. I'll change that to blue, which is super helpful.
So if it's a negative, then negative.
Yeah, so if this is like negative 3e to the power of x, this is always, always, always going to be negative, which is going to help you because you're eventually going to have to come back up here where we did this, where we said, okay, is this positive and is this positive? You're going to be like, oh, this is e to the power of x. That's always going to be positive. I don't have to worry about them. Or it's always going to be negative, so just change it at the very end. I'll review this more when we do self-checks, and you'll be seeing this for the homework tonight, and you hopefully have seen it already for the homework for a few problems before, but now it's made explicit. I'm trying to just help you guys with some tricks here and there. We're good?
Yes, sir.
All right, you may begin on the homework.